Hey, Vlad here, dependencies.com. Welcome to the final video in the Tagless Final series. Yes, pun intended. Today we're going to write some tests, fix a couple of bugs, and have a tiny discussion to conclude the series. Let's not waste any more time and get right to it. All right, now the plan for today is to simply write a couple of tests, but I'll be honest, there is really nothing to it since Tagless Final really encourages us to code against interfaces or traits in Scala, and so dependency injection is a breeze, so it's going to be really simple to write these tests. In fact, it is going to be so trivial to write these tests that I even considered not writing any tests at all for this series, but I changed my mind and I'm really glad I did. With this video, I want to make 3 points. The first one is the incredible value of highly parametric code. The second one is how incredibly important it is to write your test before you write any production code at all. And the third one, which is the most important one, and we're going to have a discussion about this at the end of the video, is that this is a simple toy CRUD app, right? There is nothing simpler than a simple, to-do app. I just said simple like 3 times. Even though we used a incredibly powerful programming language like Scala, even though we used an incredibly strongly typed technique like Tagless Final, and even though we're going to write tests, and even though this is a super simple app, we still have bugs and we still have an API in some corner cases that is not ideal, and we're going to see today when we're going to write the test, which is also why it's important to write the test before so that your API looks awesome. All right, now usually I start my projects with one of my jitter templates. However, this project was a little bit special, and so when I started it, I removed a couple of things that I thought we wouldn't need. Like I didn't think that we would end up writing tests, and so I removed a couple of test helpers and the dependencies on the test. Now I already prepared this our project for us. I created an empty project based on my template, and I just copy pasted a few parts. Let me show you. So I copy pasted only this TestSuite, which is just like 37 lines of code. We're going to use ScalaTest with a combination of ScalaCheck. And so we have this straight TestSuite, and it mixes a bunch of things from ScalaCheck and ScalaTest. And also it has a couple of type aliases for the arbitraries from ScalaCheck and for the gen from ScalaCheck and for the assertion from ScalaTest. So I put it into util and I went to the build and I made sure that that the entire domain depends on util before the delivery projects, the delivery submodules used to depend on util. By the way, we're not going to have tests everywhere because the plan for today is to simply write the tests for the boundary inside of core, and for the controller inside of the regular delivery, and for the in-memory gateway in persistence. We're not going to write any tests for HTTP4S or for skunk, simply not to waste any more time, because they're also going to be trivial, except maybe for the concurrency part. But in Tagless Final, it's nothing. There's really nothing to it. So we're going to run with bloop today, and I'm going to go over here, and I'm just going to say, so I have an alias b for bloop, and so I'm just going to say b test. We're going to start with persistence. Okay, so we have an in-memory entity gateway over here, and my template, it generated the in-memory entity gateway suite. However, as of right now, this is just an empty class. Okay, so we are over here and over here. Okay, so let me actually put this right here. We're going to have this one over here. So we're going to start by simply seeing if my test suite is actually just working. Okay, so I like to start all my tests with a simple hello world, and then do something like 1 should be 1, and then I like to see it succeeding, and then I do something like 1 should be 2, and then I like to see it fail. Let me actually have a bit more space over here so we see that it's green, and then I'm going to do 2. Okay, and then it should be red. Okay, it was red over here. Okay, and we're also gonna, ScalaTest allows us to integrate ScalaCheck, and so it allows us to write property-driven tests. And I already have a video about that if you don't know what that is. And essentially, we don't need to come up with our own examples for the values. The ScalaCheck library will come up with the examples for us. So we're gonna do something like for all, and then we're gonna ask it to generate a string like this. So this is gonna be a function that takes it, generate a string, and then it's gonna do something like generate it reverse, and we're gonna reverse again, and then what should come out should be whatever was generated, right? Because reversing twice shouldn't change the value. Okay, so it just generated like 10 tests or so, and put 10 strings in there and ran this thing 10 times. Okay, finally we can start writing some tests, and because the tests are like another end of the world, we need to come up with the effect that we're going to use, right? We need to stick something into this app. And usually it's never a bad idea to test with exactly the effect type that you're going to run in production. Like in our case, it's going to be IO. And so we're going to start with IO. So all I'm going to do is I'm going to say import cats. Okay, and somewhere inside of this class, maybe I should have more space over here. Somewhere inside of this class over here, I'm just going to say that it's going to be a private type f. I recommend you to do it like this, because then, if one day you want to change your effect type, you're just gonna, search and replace like this line through your entire project, and then everything is going to work. And the same for this line over here, effect.io. Okay, so this is going to be our effect type, and the first test that we're going to write is going to be very simple. It's going to be a very simple, read and write test. We're just going to write something into the quote unquote in memory database. We're going to read it out, and we're going to make sure that what is written is also what is read. So I'm going to call it what's written should be read. Okay, and we're going to generate two things. So we need params over here. The first one is going to be data1. All right, it's going to be to do data, and we're going to have data2. It's going to be to do data, and we're simply going to replace this line with a to do like this. Okay, now we're using if we go to the test suite, we're using a library called ScalaCheck Shapeless, which we're mixing in over here, right? So this library came in, oh, by the way, I forgot to show you one thing. Inside of build SPT, I also added the dependencies on the test libraries, okay? This is what I wanted to show you right now. So we're having this, where is it? Here, this one, ScalaCheck Shapeless, which is defined over here, yeah, right here. Okay, so what it does is it generates the arbitraries for us. However, in this particular case, it fails to generate it. It says that it couldn't find the implicit value of a parameter arbitrary for its due data, which means that this library did not generate it, and it failed to generate it because to do data, it contains a string, right, the description, and it contains a deadline, which is a local date time, right? And so the thing is that it didn't know how to find the arbitrary for the local date time. So we need to go and define it. Now, usually, and this is a thing that I really still don't like about Scala 2, and it's going to be fixed in Scala 3, that there is no good place to put these arbitraries. Sure, you can have an object somewhere, and you can just import it wherever you need. However, if you structure your application properly, if you cut it like this, then, you might have an object like somewhere in persistence, okay? But then you're not going to see it, for example, over here. Or if you define something, an arbitrary for, I don't know, for some type that is available here, but it is not available here, then you would need to create like multiple objects, and you would need to remember their names, and you would need to remember to import all of them. In Scala 3, we're going to have top level definitions, and so you can have them, you can have these implicits, laying around wherever you want, as long as they're in the same package. They can be in different submodules. They're simply going to be visible. So for now, I'm going to do something that I don't recommend you do in production. We're just going to go into the test suite, and we're going to define this arbitrary right here. Okay, so what we're going to do is we're just going to say that let's actually import. Let's start with the import. So we're going to do import Java time local date time, and now as soon as we have over here, we can make it final implicit protected val, and we're going to call it arbitrary for local date time, and it's going to be an arbitrary for local date time equals question marks. Okay, so this should be enough to get our code to compile. Okay, now the naive implementation of this arbitrary would be just to generate the current time all the time, right? So you could do something like gen delay, gen const local date time .now. Okay, and it's not const, it's const like this. Okay, and therefore over here, if we were to go and we would say print line data one. Okay, then we would see that it generated the local date time. Okay, so these are the descriptions. Let's just do the deadline. It's gonna look a bit prettier. All right, there we go. So as you can see, it just generated local date time a bunch of times. Okay. However, when you're writing your arbitraries, and even though this is not a video about property-driven testing, I'm going to mention this. Your value should not be uniformly distributed. Your arbitrary should be biased towards weird values like leap seconds, leap dates, time zone changes, daylight, summer winter time changes, and things like this. Okay. So instead of this, we're going to use the Jan calendar, which already does all the dirty work for us. And all we need to do is we need to simply map it, right? So this is going to be our calendar, and we simply need to map it to the local date. And the way we do this is by saying local date time of instant, and we're going to pass it the calendar to instant, and we're going to do calendar get time zone. In our case, this is a local date time, so we really don't care about the time zone, but we're just going to do this. We could have also used like the local one. It's probably instant. No. Get time zone. What is it? Get time zone. What did I do? Probably capitalization stuff. All right. And so now it's going to generate some really, really weird values. Okay, great. So this is all that we needed for the arbitraries. Let's continue writing the test. The first thing that we're going to do is, well, it's not the first one, but the next thing that we're going to do is we're going to look at the factoring method for the in-memory entity gateway, and it needs a RAF. Okay, a RAF of some basically initial state. So the first thing, well, the next thing that we're going to do is we're going to create a tiny helper that would improve this vector a little bit. So we're just going to give it a vector, and it's going to create the RAF for us. So we're just going to put it over here. It's going to be a tiny def. We're going to call it make entity gateway. Okay, and it's going to take the existing, which is going to be a vector of to do of existing of int. Remember, the in-memory entity gateway hard codes the type of the to do ID to int. Okay, so we need to work with ints over here. Later we're going to test. We're going to write the test for the core, and over there we will even be able to get away with something like unit because we're not going to care about the IDs. Okay, so we're going to give it some vector, and it's going to produce an f of entity gateway of f of int, like this. Okay, so all we need to do is we need to say ref, and let me import ref, which is from ScalaCheck. Yeah, let's leave it there. Okay, so we're going to do ref of, okay, and we're going to have the f, and we're going to have the vector of to do dot existing int, like this, and we're going to give it the existing that comes from here, right? This is the initial state, and now all we need to do is we need to map it to in-memory. Let me actually copy this, in-memory entity gateway dot DSL, and we need to specify the f over here. Right, so now that we have our factoring method, we need to write the program, and it's going to be similar to our regular program. So it's going to be a program of f of assertion. Assertion is something that comes from ScalaTest. Okay, it's going to be a simple for comprehension. We're going to say entity gateway, which is going to come from exactly this guy. Okay, we're going to start, please, start with the vector empty, right? So you don't have any to-dos yet in your database. Now we're going to rip out the written from entity gateway, write many, which is the not ideal API that I mentioned before, because ideally you would say, create many or update many, but we do have this like write many thing. It would pattern match on the to do. If it's data, it's gonna insert, and if it's update, if it's already an existing one, then it's going to update. Okay, right. So now this is what is written, and now let's read it out. Entity gateway read all. Okay, and what we're going to yield is an assertion, right? So this is an f of assertion, so we need to yield an assertion. The first one is going to be a read, should be read, and a read should be vector of to do and existing, and the first ID is going to be 0 with data 1. Let me copy that part, put my cursor over here. This is going to be 1, and this is going to be 2, and if it compiles many like this. All right, let me actually create a little bit more space. Now, I don't always have enough space to show you that the tests are green, so please make sure to read this line, all one test suites passed. Okay, so I'm going to create like a little bit more space over here. Okay, so this is the first typical mistake that you have, in the Tagless Final test. You create a program, but you forget to run it. Okay, because now, if we change it to 5, it's still going to pass because it doesn't actually run the program. Okay, as you can see, it's going to say, all one test suites passed. Okay, so we need to actually not forget and actually run it. So we need to say program.unsafe run sync like this, and now it should fail. Never trust a test that you haven't seen fail. And yeah, it failed, and now we're going to do 0 over here, and now it is going to pass. We're only going to have one more test for the in-memory entity gateway. We're obviously not going to be able to write all the tests, okay? And this test is going to be less boring because this one will actually catch a bug. So we're going to call it update non-existing should throw. Okay, so the insides of this test are going to be very, very similar. So we're going to have row, we're going to say existing. So what we're going to do is we're going to generate some existing to do, and then it's not going to be in the database. Okay, but we're still going to try to update it. Okay, so we're going to create a program. In this case, we don't need the assertion, so it's just going to be a program of unit. Okay, it's going to be a full comprehension. It's going to start very similar, so it's going to start like this. Okay. So as you can see, we're starting with a database that does not have any to-dos. Then we're going to have written, and it's going to be entity gateway write many of vector of existing. Okay, so again, like write many will figure out, okay, it's an existing to do, and therefore with write many we want an update, and then it's going to try to do the update, but it's not in the database, and we're going to see how it's going to behave. Okay, so we're going to have read entity gateway read all. Okay, and it's going to be an f of units, so all we need to do is we need to yield this. Okay, and so now something is wrong. Yield this. Yeah, okay, now it's good. Okay, so now all we need to do is we need to say that no exception should be thrown by program. And I'm simply doing this because, you know, just constructing the program should not throw the exception. Okay, and now I want to ask it to actually verify that an exception is actually thrown when we run the application. Okay, so we're going to say a runtime exception should be thrown by program unsafe run sync. All right, and this test should actually fail once I type it correctly. What is happening is that we actually have a bug in the in-memory entity gateway, and I already know where it is. And so if we go into update 1 and we go to the implementation over here, and then we're going to see that it basically filters out the IDs that already have this ID, but if it's empty, then, you know, nothing was gone, and then it adds it. Okay, and so it sort of tries to make sure that there will be no duplicates, right? But actually there is a way to construct a situation where there will be duplicates. In any case, I actually was planning to show this to you, but I actually don't really, I actually don't really want to waste any more time. So we're simply going to run this test and move to fix this test and move along. Okay, all we need to do over here is we need to do if as exists id equals to do id, well then please do this. Okay, and otherwise we're just going to throw an exception. Okay, now if you have seen my previous video about error handling, you're going to see that you know that we can simply what is happening exists. Okay, then you know that we can simply throw an exception, and then something will catch it inside of cats, and it will wrap it into a proper applicative raise error and stuff. Now even though our test passed now and it behaves exactly as I wanted, I actually want to improve this. Okay, so the first thing that is happening over here is that a new runtime exception will be thrown, and this is not a thing that you want to have in functional programming. Even though there's something in cats that will catch it for us, it's still really not ideal. It looks really weird that we're throwing this exception. Okay, but before we improve it, let's actually improve our test a little bit. Let's also say that we expect some specific message. Okay, so we're going to say the runtime exception thrown by and let's have curly braces around this. I believe it's going to look more awesome. Should have message. The message is going to be an interpolated string, failed to update to do. We're going to say existing ID because it didn't exist. All right, so let me actually copy this line, bring it over here. This is going to be our message, and the variable over here is called to do. Okay, so what we're going to do is we're going to do it like the proper way without actually throwing the exception. So all we need to do is we need to get the current state, right? And then we're going to flat map over it like this, as okay. Then we're going to have, you know, the same line if, right? So if this is what's happening, then we're going to have the state modify, okay, like this, and we need to remove this line. Okay, so if it exists, then we're actually going to run the modify, okay? And otherwise, we're simply going to raise the error, right? We're going to say raise error, and we're going to do, let's use these. No, let's use the regular parents like this. Now we're going to raise the error. In this particular case, we don't need to throw it. We just need to do new like this, okay? And this is it. This is the new thing. It's just that now we're actually forced to do, you know, to do the right thing, and we need to make sure that this thing over here actually has something like an applicative error, okay? But we already have flat map, and flat map was applicative. It is already a monad error, so we can simply remove all of that, and we need to say this is going to be a monad error of star with a slot and a throwable over here, and I can simply copy that. Okay, so over here it's going to compile now, okay, but now in the in-memory entity gateway we need to do the same trick, and we need to say that this guy also needs the monad error. Okay, so now it's going to behave exactly the same way, but we're not actually throwing anything. I know that this is a little bit more code, but it's a little bit more type safe and a little bit more, I don't know, it makes me feel better inside somehow. So we're pretty much done with the in-memory entity gateway, and this was kind of like the most boring one because it didn't have any dependencies, it didn't have anything. So we wrote these two small tests. Okay, so let's just simply move along to core. So I'm going to go over here. I'm going to go like this, and I'm going to say core. We're going to go to the BoundarySuite, which was generated for, was my generated template. I'm going to close everything else. I'm going to say over here extends TestSuite, same as always. Hello world over here. I'm going to say, 1 should be 1 like this. On the right side, we're going to open the boundary in the meantime, which is over here. Let me close all the others, create a little bit more space like this. There we go. Now, one of the issues that we have with the boundary is that this is a simple CRUD toy application, so we don't really have much logic. If we go down over here, there are only a few things that we could test. Like for example, in the right over here, we're making sure that we're trimming the description. So we can write a test where we're giving, some description was a couple of spaces, with a couple of spaces around, and then it's going to trim them. And another thing that we could test is that if the description is empty, for example, that it is not going to call the method that is defined on the gateway. Okay, so these are the few things that we're going to test. So the first one is going to be description should be trimmed, okay, like this. And so what we're going to do is we're going to look at how to construct a boundary, which is the same thing as we did with the memory entity gateway. But the boundaries are awesome because it actually needs something to be injected, which is the entity gateway. Okay, and I prefer to put my fakes into the companion object. So what we're going to do is we're going to go over here. We're going to say import BoundarySuite like this, and we're going to define it over here, object boundary suite like this. And what we're going to have inside is going to be a private class, and it is very important to make it a class because it will force us to implement all the methods. Okay, so some f, some to do ID, ID extends entity gateway of f, and to do ID like this. Okay, and now it's going to force us to implement all the methods. We're going to use methods for this. Let me remove this empty line, and create a little bit more space. Maybe remove this empty line, and maybe remove this empty line like this. All right, so the next thing that we're going to do is we're going to go and we're going to try to construct this fake entity gateway. But it's very important to test everything through their boundaries, right? So through their traits. Okay, so make sure to specify the types over here, right? So this is going to be not the fake entity gateway. It's going to be the actual entity gateway. Okay, and we need to come up with some effect type. We need to come up with some type for the ID. And for now, we don't have any implementation like this. And now we're finally going to start to reap the benefits of highly parametric code. In this particular case, we will actually be able to get away with a very, very simple effect type, which is not even an effect type, which is simply ID. And a lot of people, well, not a lot of people, but some people don't like to test with ID because it doesn't really represent what IO represents. Nothing is delayed. But still, in this particular case, this is an educational video, so it's kind of cool to know that this is possible. Okay, so this is going to be our effect type. Okay, this is going to be our F. Okay, and in this particular test, where we only care about the description, we don't really care about the ID. So we're simply going to use the simplest type that can have inhabitants, right? That can have instances of it, which is not nothing. It is unit. Okay, because we don't really care about the ID. So it's going to be unit. And now over here we can say let's do a new fake entity gateway for F and for unit. Please make sure to specify these types. If you leave them out, it's still going to compile, but it's going to infer nothing for both of the parameters. Okay, specify them. All right. Next thing we're going to do is we can finally construct our boundary F unit. Okay, it's going to be boundary.dsl, and then we're going to give it the entity gateway. And for the first time, we should see right now that our tests are going to fail. As you can see, it failed, and it says a not implemented error. This is very, very weird because we're just constructing an application. We're not running anything yet, and it already throws an exception. Now, you might think that this is because we're using an eager effect type like ID, but in fact, something else is at work here, okay? And this is the root of all evil, which is the premature optimization. Somewhere inside of the boundary, if you look over here, it actually throws at fake entity gateway.readAll. So something inside of the boundary during its construction time calls readAll. Okay, so what's happening is that in a couple of places we said we overrode a def was a val. Okay, so if I look for override val, I'm going to find exactly this. And there are two of them. There's one for read all and there's one for delete all. Okay, so all we need to do is we need to say, well, this is not what I wanted. It was the Control Shift. Okay, so Control H should be able to replace override val with override def. Okay, like this. Let's go do this. And I think it did, right? Here and here. Yeah. So and now our test should be back to green. So this is always how I start. I usually fake things. They don't have any implementations. I want things to be green, if I didn't, if I haven't done anything yet. So now we can finally write our tests. So we're gonna go and we're gonna say, hey, please generate some data to do data, okay? And I'm just gonna say that whatever comes in, create one data description should be data dot description dot trim. Okay. Now this might not be such a perfect test case because we don't always know that it would generate a description for us which will have actually spaces around. Okay. So we could go and say, okay, sure, you generated the data, but let's make sure that we're going to copy. I'm going to say description equals data dot description plus a couple of spaces over here, and also a couple of spaces over here. Okay, so I'm gonna leave it like this for a bit, but in fact, a bit later I'm going to remove it. Okay, but for now I'm gonna leave it like this. Okay, so right now it fails. It fails for the reason that we don't have anything in the fake entity gateway. Okay, it says an implementation is missing. Okay, in this particular case, it calls the where's the stack trace? Where's my stack trace? It swallowed my stack trace. Not implemented was thrown, blah, blah, blah. Really? All right. Now, in this particular case, I already prepared, so I know which one it is, and it is the write many. Okay, so if I do override write many, okay. Now, for some reason, if I press tab, this is currently a bug in Metal, so if I press tab, it will insert the override keyword twice. Okay, I don't know why it's doing this. Okay. All right, so we have the override def write many, and now look how awesome it is. We don't need to deal with any effect tests, with anything. We're just going to grab the to-dos. We're going to pretend as if we're writing them somewhere. So we're going to say if it's data, and this is the not ideal part about the API. We shouldn't need to write so much code as I'm writing right now. So if it's basically an insert, then we're just going to generate it. To do existing, we're going to give it some ID, which is going to be a unit because we don't really care, with some data over here. And if it's an existing, to do an existing with a unit, we're simply going to return it. Okay, return it like this. Okay, and this should already be enough to pass our test. And look, we don't need to do like something like pure AF. We don't need to do like some crazy flat maps or maps. Like over here, we're doing map on a vector, right? We're not doing a map on an AF simply because it's an ID, right? And we don't care about the to-do ID, so we're using unit. And this is the value that you get from a highly parametric code. Okay, I'm going to remove this thing because I don't really care about being so precise about such simple things. Okay, great. So the next thing that we're going to do is we're going to make sure that over here that if the description is empty, that this method is not being called. Okay, and this is going to be the last test that we're going to write for the core. Okay, so let me collapse this one. Okay, so I'm going to say test. I'm going to say read by I think it's called read by partial description, but I'm just going to say read by description. Should not always. I was a bit too pedantic with the names. Call gateway read by description. Okay, as a name of the test, it should be fine. Okay, so some people don't like to use mutable variables, because it's functional programming and whatever. I'm not a purist. I don't really care for really tiny things like this. So this is how we're going to measure if the method was called or not. We're just simply going to say was called is false, and then we're going to create an entity gateway, which is entity gateway for F and for units because we still don't care. Okay, I'm going to say new fake entity gateway, maybe tab of F and unit. And in this particular case, we're going to go and we're going to override read many by partial description in this one. And again, we have the override twice. All right, and so over here, the first thing that we're going to do is we're simply going to say that was called equals true. Okay, and then we're going to return some empty vector because we don't really care. Okay, so now we can construct the boundary. The construction of the boundary is going to be exactly the same. So let me just copy that. So over here, over here. So we're constructing our boundary. Nothing should throw any exceptions because we're still just constructing a program. Now, ScalaTest has a couple of really cool print line like methods. One of them is info, so you can say info blah, and it's going to sort of participate in the name of the test. Okay, so it's gonna appear over here. And the cool thing about it is that I don't know if you have a couple of them, right? So this is going to be the first one, and this is going to be like the second one, and this is going to be the third one, right? And if the test fails like somewhere over here, right? So over here, let's let's throw an exception, sys arrow, boom. Then these methods, the output participates also in the color. So as you can see, you see over here, first and second, they were red, and then you see, okay, then something failed, and you haven't seen this one, okay? There are also a couple of other ones. There's when, and so there is like given, and there is when, and there is then. Notice that the names are capital. Exactly the same thing. It's just that they insert these words. Okay, so it says given first, when second, then third, but we didn't see the then third. Okay, like this. Okay, and by the way, in the test suite, if we go to the test suite, here they are. They're coming from this trait, given when then. Okay, the info is always there. Given when then is not always there. Okay. So we're going to use them to have multiple assertions in this test, and what we're going to do is we're going to say, when the description is empty, right? So we're going to do boundary read many by partial description. Okay, and again, like if this code throws an exception, then this is going to be the last print line that you're going to see. Okay, then gateway dot read by description should not be called. Okay, and so we're going to say was called should be false. Okay, and this is how it looks like now. Okay, there we go. When the description is empty, then gateway read should not be called. Okay, nice. Okay, and now we're going to have another one over here. We're going to mix the simple test with a property-based test. So we're going to say for all, and for this particular case, it's enough that it runs only once. And so we can say as soon as you see one successful one, you can stop generating the values. So we're going to have some description. It's going to be a string. Okay. Now it's going to generate a bunch of descriptions, even the ones that are empty. However, we can say whenever description is not empty. Okay. Then we're going to say when the description is not empty, okay, then boundary read many by partial description with this description like this. Then, whoa, what did I just press? Then, whoa, yeah, I recently switched to WSL2. Reconnect now. Whatever the hell was that? Whatever the hell that was. Okay, so we're gonna do gateway read by description. In this case, it should be called. Okay, so in this case, was called should be true. Okay, like this, and this is how our output is going to look like now, right? So we have sort of like this becomes, it used to be just a test, but now it sort of becomes like a category of tests, and both of them passed, right? So this one and this one. Notice that, as a reminder, they're just print lines. Okay, so if we didn't have this thing over here, okay, then it would run a bunch of times. It would still pass, but you would see this print line many times, right? This is how you see that. Okay, ScalaCheck generated, I believe, 10 of them. Okay, 10 of them, and this is the previous one. Okay. Let's remove this. Okay, let's revert to that. Okay. All right, so this should be enough for the boundary. So we have now the persistence and core. We have both of them, and there we go. They both pass. By the way, when you're passing the parameters like this to Bloop to run these tests, for some reason it runs them in reverse. So the first one that was executed was the core, and then it was persistence. Okay, as you can see. Right? Cool. So this should be enough. We're going to switch to writing the test for delivery. I hope that this video is not going to get so long. If it does, then I'm going to split it into two.